Hello YouTube, this is MusicDude14Z, and I'm here with logic gates. These are our first two logic gates, the OR and the NOR gate. Uh, the NOT gate, which we did 2 lessons ago, is technically a logic gate, but it's very simple. Here's where you have to think about stuff and everything. So, to help lay it out for you so you can expect what each gate will behave like, I made what's called a truth table, which gives possible inputs, and we're working with just 2 inputs for now, and the output that happens for that specific gate. Each gate will have these same 4 inputs, which is on off on, and off off. And then depending on the gate, the outputs for those inputs will be different. That's what makes each gate different. That's the good part about the gates. They can do all sorts of different combinations. So this is an OR gate. Oh, and if, by the way, if it helps, you can imagine these as either ons and offs, trues and falses, or ones and zeros. 1 and 0 is probably the best way to look at it. I'm going to say on and off because these are redstone lamps and they're on and off. But 1 and 0 is kind of how you have to look at it if you ever want to go into complex redstone and do binary and everything. You need to be thinking in ones and zeros. Alright guys, so here we are. For an OR gate, if you think about it in English language, when you say, I want this or that, it means you'd go with one or the other or both. Why not? So you can see if you have on and on, you get an on. If you have on and off, you get on. If you get off and on, you'll have an on. But if you have neither of them, off and off, you'll return off. So that's the basics of the gate. And now we're going to go learn how to build them and different styles you can have. Be right back. Alright guys, here I am, and I'm about to show you guys how to do logic gates. And my lamp got destroyed. There it is. Alright, so in this tutorial, we're going to treat these as my inputs and this as my output. So, right now, we need to find a way so that when this is on and that's off, this turns on. When they're both on, it's on. And when that one's on and this one's off, it's on. But when they're both off, it's not, because that's what we just discussed in the previous part. So whenever there's power coming out of either lever, wow, that was a jumble. Then we want it to go straight into this redstone lamp, and the redstone lamp should turn on. So what if we just combined them into one power? Let's test it. It's on. It's still on. Still on. And it's off. There we go. That's an OR gate. Remember, this design concept is expandable to as many inputs as you want, and although the truth table we looked at doesn't have this many inputs, the logic behind this would be whenever any single lever is turned on, the redstone lamp should go on, and no matter how many more you flick after that, as long as there is a torch on, the redstone lamp will be on. Only when all of them are off will it turn off. Okay, so let's look at some basic and common designs for OR gates. Here's the first one. Takes 3 inputs into one piece of redstone and goes into that. I'm not going to show you all the possible combinations of the 3 because I think there's 12 and that's quite a lot, and I don't quite have time for that. Or maybe it's 8. I think it's 8, but whatever. Still, it's a lot. Here's the exact same thing, but using a double NOT gate or repeater, which does something that this doesn't. It isolates the inputs. When I turn on this input, it doesn't affect this input or this input. And on a sensitive circuit where you can't have the power flowing backwards, this is very important. Also notice how when this is powered, the output isn't being directly affected by these, and it's not affecting these either. So therefore, the inputs and outputs are isolated, which is a very important thing. Alright guys, so let's turn that off and go to this one. Here's another way of isolating the inputs, by putting them behind repeaters, because power can't flow backwards through repeaters. Notice how these aren't lit, even though this one is. There we go. Here's a vertical one. So if you have power coming in vertical directions and you need to fit in a 1 horizontal space, this is the method for you. So turn that on. Turn that on. Off. On. See, it works. The only problem is, since this has a double NOT gate, which has 2 ticks delay, and this doesn't, it's recommended to add a repeater with a 2-tick delay, so that they're both even. However, this NOT gate is also a good idea because it isolates this input, which wasn't isolated before, because when I turned this one on, that one was getting power. And it's nighttime. Why is it always nighttime? Alright. As of 1.3, there's a great new design for an OR gate using half slabs, because as you can see, when a half slab gets power, it goes up onto the half slab, but not back down, which allows us to create an excellent OR gate that can be expandable for quite a large while. This could keep being repeated and repeated, and you can also, in between these, if you had to repeat it for long enough, add a repeater, because repeaters can be passed on half slabs just like redstone. So that is awesome. I actually really like this OR gate. It's a little bit it takes up a lot of space, but it's good for certain kinds of circuits that where the inputs are kind of coming from all over. This one could work really well. Okay, so that's pretty much it. Now we're gonna go on to NOR gates, and I'm gonna go switch over to the truth table. Alright guys, I am back with our next gate. This is the NOR gate, and it's pretty much the same as the NOR gate. Well, actually, it's the exact opposite, which makes it pretty similar. For all the inputs that led in a on output for the OR gate, we get a off output, and for the one input that gave an off output for the OR gate, we're getting an on output, if that makes any sense. So we can just look at that a little more simplified. When you have an on symbol, we get off. If we get on-off, we get off. If we get off-on, we get off. And only if we have off and an off do we get an on. And you can think about this in the English language. I don't want that nor that, meaning you don't want either of them. Alright guys, we're going to go learn how to build this gate now. Okay guys, so here we have our two inputs and our output. And we want to make it so that in this position when they're both off, this is on, but at no other times it is. But if, as we said before, it's the inverse of a NOT gate, of an OR gate. Hence, NOR gate, not OR. So, why don't we make our OR gate, and then negate the symbol, the signal. Jeez, I always say symbol. Alright, and see? Works just like we expected it to. So let's go look at, and we can look here and see it's also expandable, just like the OR gate, and it does, and has the exact same function, except when all the levers are off, the lamp will be on, and in no other case will the lamp will be on. If you flick any levers, no matter how many of them, the lamp will be off. Alright, I have an annoying cow in the way. Alright, there we go. So, remember when we had the three inputs going into a double NOT gate? Well, here we take away one of the negations, so it's only a single NOT gate, and works all the same. Therefore, we have three inputs, and they're all isolated, in addition to the output being isolated. So this works pretty well. Here we have the same concept, except we take a fourth input and power the block from above. So therefore, we have a four-way, instead of three-way, NOR gate, which works pretty well, actually. The only thing I don't like about it is it's kind of huge, and it's a little bit unnecessary to be that big. For you can always just take one of the OR gates that you like best and put a negation at the end. That's probably the easiest way to do this. So, excuse me, sorry guys. So if you see this, it works just the same as the OR gate until we negate it, and then it works like a NOR gate, just like it's supposed to. Then I also took the liberty of taking the one horizontal one, the one that's meant to work vertical in a small horizontal space, and I've set it up so that it works just the same by adding a NOT gate over here before the lamp. But if you guys notice, we have three NOT gates like that. A little bit on the excessive side. So we can see here it can be condensed down, and a repeater can be added to both. Even though this one doesn't really need it, it's good to keep it even, so that inputs are both isolated, and so is the output. And there we go, guys. That's pretty much it on the redstone. So, this is Music Dude 14Z with my skin finally working. Yes, this is awesome. And I'm signing out. Thanks, guys.